Hi everyone. So today we will learn number system, which is an interesting chapter in computer for class 7 ICSE board, and it's very important to learn this number system in order to understand how our computer interact with us and what's the language that computer understands. So let's go and find out what are the learning objectives that we are going to learn within this chapter. Firstly, what is number system? Then there are two types of number system which are generally used: decimal number system, binary number system, then decimal to binary conversion and binary to decimal conversion. If we move further, we will learn what is number system. A number system is the method of representing numbers. Computer uses different number systems to process data. The two most important number systems are decimal number system and binary number system. So with progress, we will understand better why number system is required, why the computer uses this number system. So let's start with decimal number system. The decimal number system usually uh, are calls the 10 digits starts from 0 and 9, but it doesn't means that it ends at 9 only. By combining this 0 to 9 numbers, we can create multiple amount of decimal numbers which falls under decimal system. For example, which is provided over there 245, which is a combination of 2, 4, and 5, 7, 8, 6, 1, 0, 2, 4. Another important characteristics of decimal number system is base. The base of this number system always is 10, and this number system is used in a daily life. So it's a very common concept, as we have understand that this number system is highlighted with the power of 10. For example, 345. Let's consider it as a number. How we can break it in order to understand the place value of each and every number within this 345. So 3 is there, which is in a 100th place, 4 is there in the 10th place, and 5 is there in the 1th place. We move forward. Binary number system, another important type of number system. It is also known as the language that the computer understands. It consists of only two numbers, 0 and 1, and there are different type of combinations of these two numbers that are made in order to make the computer understand what type of input that we are providing. For example, we have our mother tongues, we have English as a common term to give instruction to computer, but similarly computer has its own tongue or own language system that it understands, which is called as binary language, and which is constitute of only two number, which is 0 and 1. So similarly, any instruction with any language that we provide are being processed within the processing unit, and it is provided in the form of 0 and 1. For example, the combination of 1010, 1101, 1001111. This all holds a different type of language that we are inputting. It's been processed in these numbers and been given to the computer for depicting an output. Now move forward. Why computer use binary? For example, over here you can understand there are two states of a circuit for one and off, on and off, right? So if we provide an instruction to computer that please turn on this device, in place of on, the processing happens in such a way that it will replace with 1. Now 1 means on for computer. So the statement will sound like this: please turn on, no, please turn 1. Please turn off, in place of off we will say please turn 0. So this is how the process happens, and the language that we provide the input with is being transferred in a binary language. Now let's understand the place value in binary system. As we have learned that decimal has a place value of 10, so the binary system has a place value of 2. For example, 1011, and the 2 depicted at the bottom, it states that it is the base is 2 over here. Now, for example, let's look at the table first. The binary digit, first one is 1, 2 to the power 0 means 1, 2 to the power 1 means 2, 2 to the power 2 means 4, 2 to the power 3 means 8. So while depicting, or while we will perform the calculations with this binary number in order to bring it to the decimal form, what we need to do? we need to start it from the opposite side, which is if it starts from 1, then 0, then 1, then 1, but the place value will start from bottom. Means first the first one will be multiplied by 8 as there are 4 digits. The next one will be multiplied by 4. The third one will be multiplied by 2. And the last one will be multiplied by 1. Understood? So after doing the multiplication, what we get? 8 plus 0 plus 2 plus 1. It means 11 and to the power 10. Why? Because we have transformed this binary system number into the decimal place number. Okay. Now let's go to the next one, decimal to binary conversion. Here are the steps how we usually do it. Divide the decimal number by 2, write the remainder, continue dividing the quotient by 2 and stop when the quotient becomes 0. Write the remainder from bottom to top. Let's look at the example. Let's look at the table right now. Okay. So the number of that is provided to us is 10 to the power 10, which is in a decimal form. And how we will convert it to the binary form? First, we will divide 10 by 2 as the binary base is 2. So the quotient come is 5 and remainder is 0. Then we will again take that quotient and divide it by 2. So the quotient will be 2 and the remainder will be 1 this time. Again, we will take the quotient and divide it by 2. Again, the quotient will be 1, the remainder will be 0. And again, we will take that quotient unless at it has been mentioned in the step, unless the quotient become 0 after dividing 2, we will continue this process. Once this is done, we will look at the remainder and from the bottom, as we have identified before also that to identify the binary numbers, we will always take the number or we will always start the number from bottom. So the first number will be 1, which is at the bottom, then it will be 0, then it will be 1, then it will be again 0. So 10 to the power 10 will now be converted in a binary form, which is 1010, which base is 2. Similarly, let's try this number also, 25, which is in a decimal form as the base is 10, and 11001, which is in a binary form as the base is 2. Similarly, we will divide 25 by 2, 12 by 2, 6 by 2, 3 by 2, and 1 by 2, and we will get our binary form in the remainder, which is 11001. I hope you have got this. Let's move to the binary to decimal conversion. Now the steps are: write the place value of binary digit, multiply each digit with its place value, add all the results. Let's look into that same. Now the binary number is provided to us, which is 10101 to the power, or the base is 2. And we need to find out the decimal version which needs to come is 21. So how it will come? The first number is 1, which the place value which it holds is 16 because it's coming in the fifth place as we have identified before only. So 2 to the power 4, it will be 16, then it will come 8, then 4, then 2, then 1. But the result will come how? By multiplying the first binary digit number with the place value. So 1 into 16, it will come 16, 0 into 8, it will come 0, 1 into 4, it will come 4, 0 into 2, 0, 1 into 1, 1. And after adding all these numbers, it will give us the decimal place number, which is 21. So the simple advantage of using this binary system is it's simple and reliable for the computers as they understand this language. It is easy to process electronically and reduces the chances of errors. Okay, I hope you have learned and you have understand this concept in a better way. For more clarity, contact us, join us. We'll be happy to help you out. Thank you.